hundreds of exploits. Those are exploits can be launched clients, the HTTP tunnel, try and get after the remote kernel, the OS kernel for the web server. Can anybody guess what the major countermeasure is? No guesses in the chat. Encryption. Encrypt your sensitive data. And harden the underlying OS and patch it. Alright. From the design standpoint that we can attempt to secure the web servers. Put it in a there is no reason that it should be on the internal LAN and exposed out. We looked yesterday at ideas like backing hosts and DMZ. For these servers that need to see the outside, we are going to have the router. We are going to have firewall. This firewall incoming rules aren't going to be as restrictive as this one because we need the data to pass to these servers. But on the other side, we have the firewall, and our ingress rules are much stricter to protect the corporate network. So that's the first thing, is that you have placed it correctly in the network design and that you have done the correct ACLs on your firewall. Now, a lot of times, you're just renting or leasing the web hosting from a third party, and they will have figured that out and set it up correctly. All right. Countermeasures. Do I need to take patching and update by Thursday, or do we know? Encrypt it. Change your default passwords. Do your patching at OS application firmware, every level of the IT structure. Make sure you get peer review your service packs and hotfixes. Some of them will cause problems, so you need to put it in an area where you can test it to make sure that the patch doesn't break something. Apply all the updates instead of just as needed. Internal LAN, sometimes we won't install an OS update because we're not running that service on that machine, so it doesn't need it. Forward-facing servers, everything. Every single patch that you can that doesn't break. Okay? Make sure that your domain controllers are at the same patch level. That will create some issues. Make sure that you have backups, fault tolerance, redundancy, off-site data backups, however you guys want to do that. Have a backup plan anytime that you're doing a patch upgrade in case it does take the system. And schedule those upgrades as part of operations and maintenance. The rule of thumb is to never be more than 2 patches behind. I wouldn't even do that on the internet. Those are critical. You get them as quickly as the testing process is done. All right, protocols and accounts. Do we know this by now? If it's not a protocol, not a service. Disable it, offload it if you can, turn off the port, okay? Don't use unencrypted or insecure protocols for secure data, definitely not for any sort of authentication. Disable the web distributed authoring and versioning WebDAV if your application isn't calling on it. And that is something that you would have to reach back and discuss with your developers, okay? Enforce TLS as appropriate. Remove all unused modules, scripts, accounts. When you create a web directory, grant least privileges, right? Least privileges. And you not only want to do that for the account that's accessing it, but go to the file and folder permissions, those NTFS permissions, and block it down. For any sort of password hacking, go ahead and implement log out, 3 or 5 that attempts, lock the user account for X amount of time. And then those things like THC hyper severely longer process. Make sure that you're auditing failed to log in attempts on your web server, and make sure that the logs are being taken off your web server to a syslog server, that they aren't being stored locally. Use a VPN when appropriate. Most applications in this day and age for web reach back to the database server, so you're going to want to look at making sure you have the minimal accounts and that those accounts have the appropriate ACL to that SQL database. Where appropriate, use two-factor authentication for your account. All right. When we are looking at our files, so forth, eliminate the unnecessary .jar files, JAR files, jar files. Okay? If it's not being consumed by the web service, get rid of it. Avoid mapping virtual directories between servers. That just gives a pipe. Remember, the pipes are server communication. Just gives the attacker a pipe into the other servers that are out there. Look at your logs, have logging at the OS level, the web application level, the database level. Don't allow directories to be served up. It makes it much harder for us to figure out the hierarchy on the server. Eliminate. Anything not absolutely needed and in use, get off of it. So any of your backup files, your text files, which should never be backed up the web server to itself. Disable the serving of certain file types. You can do that in the configuration resource mapping. We are probably going to disable things like batch files, VPA, the scripts that are typically going to carry malicious code. Make sure the scripts that you do need that are supporting the web service are in a different partition from the operating system. So if they do exploit the script, they're kind of sandboxed. They're not going to be easily exploiting the underlying OS because of the device. Detecting the web server attack. A couple ways you're going to be, first of all, putting on what we would call the file integrity monitors, the FIM. Tripwire was the one that we introduced to you a couple of days ago. So we're going to run that against our critical core files on the web server, store the hash values offline, and then we can run those hash values again and compare them. Tripwire can do this automatically and send you an alert when something has changed against the hash value. Alright. I don't think I need to tell you this. Make sure you're on the There is configuration that if somebody comes on in at HTTP, forces them to an HTTPS connection. Server certificate. Make sure that we've got our certificate from a trusted certificate authority, that it is valid, that it's not expired, that it's not been compromised. Go to GoDaddy, Verisign, whatever, and put that out so it's a public key, and that the user's browsers can double check for that CA and the authenticity of the certificate. Machine.config, Apache. Okay? I don't know if you guys know, but all Windows files are 3 letters, sometimes 4 because we have the new doc.x, doc.m. But if it's more than 4, it is a Linux file system. It's just a good little way to know what we're talking about. Machine.config is going to be literally configuration level information about that server. So what we can do is disable our tracing. That is debugging information, change that value to false, so we aren't showing information to an attacker. We can do what's called the HTTP forbidden handler, making sure that if the correct resources are mapped, that literally is saying if this resource is mapped to this, it was not serve over the HTTP request, okay? And that any non-needed HTTP modules are moved, eliminated, however. The majority of websites are compromised because of bad configuration or not secure coding practices. I believe I said this yesterday. The majority of your program developers, their metrics, how they get raises and reviews, and their entire focus is stable and deployed. Very rarely is the emphasis put on and secure. So we need to make sure that we, as security professionals, are doing that. And a couple of ways that we can do that is have IIS inject anything to SS directory traversal attack of the .flag. Harden our ACL. Restrict access to the actual code. Securely store the code and the backup worked on. There are now classes out there for developers that market for security code and how to secure programs. And your guys, your developers, have that. And still defending against web server attacks, restrict your ASL. If it is a standalone server, meaning that it is not part of the domain, then all of the accounts are stored locally in the secure account management of camping to make sure that you secure that because you don't join web servers to the domain. So they are going to stand alone. Make sure that you use NPS permissions to remove any ICAP input filters. They're not needed on it. The default changing all that. Relocate virtual directories to non-partition. Your OS should be on one partition, and then everything else should be on other partitions. You don't just want that all on one drive, one logical drive. Remove any of the script mapping, and a lot of these, you gotta monitor to see if you're in the public. Then breach or infect. Use a dedicated machine for the server. It should never, ever, ever be on a domain controller or something else that is DNS server or anything like that. They stand alone because they are so prone to be compromised. Create your URL mapping. Don't install IIS on the domain controller. Use server-side session ID that will get you around any session fixation attack. So after the TCP, have the server create the session ID and send it back. If you've got to have a database back in, if the SQL installation needs to be on a different server than the web application. Of course, use your security tools, things like that. Physically protect it. I think we know by now. Physically protect the access to the assets. Do not connect an IIS server to the internet until you have fully hardened it. The minute it comes up, it's going to be under attack. Okay, so and that's hardening to the OS, IIS, the accounts, and everything. Okay, do not allow any accounts to have a local logon except for the local admin account. Have separate anonymous user accounts for each application if you're hosting more than one web application on that server. Only support technologies that are being used, and of course, screen and filter incoming requests. That's where your firewalls and those details are going to come into play. Do I need to talk about patching? Can I see you guys in the mini chat? Do I need to tell you any more to patch your stuff? Okay. No? Yeah, we've gone through it many times. For our application developers, we need to restrict a couple things. The first thing that we're going to do is restrict the web application access for unique IPs. Okay? We should have it programmed that we are not going to allow carriage returns. The LF is kind of like a tab. Those any of those characters we don't want. We'll see in the SQL exploit why. Okay. There is RFC 2616. That is the standard for HTTP version 1.1. Make sure that anything that you're deploying forms to them. For proxy servers, don't allow TCP connections to be shared among different clients. Use different connections and proxies if we're going to different virtual hosts, and have the configuration maintain the request host header so that the header splitting can't. So, I like your response, Contrell. Thank you. All right. Defending against any of those DNS spoofing, DNS hijacking, and so forth. Make sure that you are getting the true IP address from the Internet Corporation for assigned numbers, ICANN. What you're actually going to do is go through your regular stuff. And then here, it's Aaron. We've got ethnic and Pacific. We've got African for Africa. Right is Europe. Okay, go with this. Make sure and have them set what is called a registrar lock, which means somebody can't go and make changes. They'll have multiple ways to confirm your identity before you're able to change anything to the DNS registration. Okay? Safeguard the account information that actually went out and procured your IP. Most of your ICANN accredited registrars have that as a service, and they'll blank out the information in the WHOIS record so that you can't extract the username, the IP of the machine that the request was made from, and so forth. Make sure in your incident response plan that DNS hijacking is something that you have addressed. Monitor. Some of the third-party monitoring tools, most of your registrars, again, are going to give that as a service. Take your people on that one. All right. Needless to say, we go through every chapter, and then we've got some scanners and tools that are going to help with our automation. Hybrid is a different website. Cross-site report, 4543. Reversal, SQL injection, all of the types of attacks, it can be vulnerabilities that can be exploited. Stalker, same thing. It also does click checking and so forth. More scanners. Flawless. Flawless is a multi-tool scanner. It, yes, can do regular vulnerabilities, but it also does have the ability to have a web application. Nexus is the same way. They have a template for web servers, web applications, SQL servers, and again, we're seeing Tick2 here at the certain.net location. We also need malware monitoring tools so that evil guys can't go and make our server the one hosting. QualityGuard has malware detection. Web inspector and so forth. What I would say to you is make sure that you're not spying a host malware like Norton. Make sure for the malware monitoring that it is one that's capable for known web server attacks. And there are security tools for web servers. I keep stressing that because they're tuned differently. They have different databases, different behavioral analytics that they're looking for a web server attack. Fortified, it not only does testing, but it also can be used in a defensive manner. It must adapt for web hierarchy. It's a very, very specific red, something that is found that is at risk. Another industry standard is Actinetic, and so folks intercept that to the servers. We have penetration tools. The idea of this testing is what we do as an ethical hacker. We're trying to get into the network. So Core Impact has a suite of tools for the pen tester. It's going to scan it. It's going to try to find its configuration for firewall. Here's a list of some other pen testing tools. Merck suite is part of that as well. And no shot that I have Alright, sorry about that. Let's talk about patch management concepts. We've talked patch. I promise you, this is the last time we're talking about patching, but we're going to talk about the life cycle and the management of patching. We, first of all, want to understand the differences in a hotfix, a patch, and a service patch. A hotfix is for a specific customer issue. Sometimes it's released to the public at large, sometimes it's only to the organization that's having that issue. Okay? It is a specific issue. A patch is going to be, hey, there might be security problems, might be errors, we're just trying to fix something that's already out and deployed. A service pack is a
Okay, gotcha.
and introduces a new feature. Okay, that's what differentiates patches from service packs. So you need to be on top of the game and get notification when there are patches available to you. The vendors that you are supporting, you can go out and subscribe. There are meta subscriptions that would give you every single vulnerability that go out there with your in the job role and subscribe to every technology that's under your purview. Um, the idea of